Okay. Good morning, everyone. Welcome back to College Algebra. So,
Good morning.
good morning. Let's see what we're gonna do today. So, I heard that some professor just told me that I don't think we can come back to normal until the end of 2021. That's crazy, right? So it means it means that all the class will be online again on summer and on fall. Wow. I was like, really? I mean, even though that we have vaccine already, but the number of cases is still increasing. That's really bad, right? I don't know why. And I mean, I'm not expert in that, but I just feel like it's not real anymore, you know? But anyway, that is politics and that's the news and stuff. We had to come back to our math anyway. So let's take a look at our module. And let's see where we've been at. Some of you already submit assignments, which is that's really good. Okay, I'm happy about that. So keep working on the assignment. Okay, keep working on the assignment and submit it on time. So we are right over here. Okay, section 3.1, 3.2. Today is Thursday, January 28th. 3.1 and 2.10. I think that you guys already watched on the video and assume that you guys already watch it. So today I just go a quick summary on that video. We talk about function. Then I give you some example on how to find the domain of function. In the video, actually, I give you some basic example of finding the domain of a very basic function already. For example, like a radical function or rational function. But I'll give you more example today. Okay. Any question for me before we really start? Good. So I mean, you just need keep working on the homework, keep working on the assignment, submit it on time. We have a test very soon, so I already said on February 8th. We're gonna do the review. I will show you what it really look like. It could be very easy, don't me. It's not really as hard as the assignment, so don't worry too much about that. But I mean, again, you still have to do problem every day, learn every day, watch the video. Make sure you watch the video. Okay. I know some of you busy, but you have to watch the video before coming to class. Then I said, okay, this today, that day, you had to watch a video before coming to class. Then you should. Okay. Just give you the general idea what I will be talking about on the next few days. All right, so no question. Let's get started, guys.
Wait, I actually have one.
Oh, you have one. Okay, go ahead.
So yesterday I was on the Open Math website, and it said, redeem this one late pass. You have 4 late passes, redeem one to finish the other assignment, because I completed one of the homework assignments, but the other one I didn't start. So I clicked redeem the late pass, and it took me back. It took me to the assignment that I already completed, and it used the late pass on that one instead of the one that I didn't complete. So now I have 3 late passes left, and it used one of them on the one I didn't even need it for.
Oh, okay. Which one is that? What section?
The very first homework. I think it was.
You mean the 2.5 one?
Yeah.
2.5. I will open that for you. So Max, right?
Yes.
Okay, so after the Zoom meeting today, I'll try to open that for you again. Let's see what's going on. And I already said this is the free version platform, guys. This is like last semester I used this, and it's something even the due date, they mess up with the due date. You know, I set up one due date. On my screen is still correct. On my platform is still good, but the student platform is different. So it happened. But I mean, I'll try to fix this for you to give you another test. Okay.
Thank you.
Any other concern? All right, let's get started again. Excuse me. All right, everybody can see my screen now. All right, topic today. Finding domain of function. I hope that more than 50% of you already watched the video. So anyone can tell me what is function? What the function is? Give me the definition of function. How you understand function? What is function? Anyone? Come on. Oh, how about what is domain? How you understand domain? What is domain to you? What does it mean to you?
Isn't the domain X?
Domain is X, and it's correct, but it's not 100% correct. Any other one? But it's still good. It's not 100%.
Is the function formula y equals mx plus b, or is that something else?
Y equal to mx plus b is the one of the function. It's called linear function. Okay. I think for intermediate algebra, we already talked about that type of function. Maybe in this course, we're gonna talk about that again. But y equal to mx plus b, so f or fx equal to mx plus b is linear function. Okay, but just one type of a function. But my question is now is, what is function? What is function? What is domain? What is range? Or maybe I'm gonna put that type of question on the test. Who knows? What is range? What is domain? Domain. Luke said that this is the x value. It's kind of good, but it's not really excellent question. But it's still okay. You still get some credit for that for such answer, but you're not gonna get the full credit first. What is function? Come on, you already watched my video, right? Just admit it or not. If you have not, just admit it. Come on, guys.
I'm being honest, I haven't watched it.
Yeah, watch. Come on, just admit it. So we have how many students? We have like 15 students over here. How many of you already watched and how many have not watched? Come on, let me know. Just say no if you have not watched.
I haven't watched it.
You haven't watched it.
I
haven't. Okay. Okay, again, you should, okay? You have to.
Is function inputs and outputs?
The function is something with input and output. This is 80% correct. Very good. So you already watched the video, Natalie?
No, I didn't watch the video.
You didn't watch it. So you just in your mind, and you already learned from the past, and you know that that's what function is. So your own opinion on function, the definition of function. Okay. So I can say that more than 50% of you have not watched the video. Please watch the video. I know it takes time, but I mean, for any lecture, just think about it. Any lecture, it will take you at least 1 hour and 50 minutes. Okay, you have to spend time on it. You have to. This is a part of learning. You know, you're not gonna be successful in the course if you just doing the practice problem exercise and you do the test, because all the tests and the practice exercises are based on the lecture, based on the video. Okay, so let me give you a quick summary of what function is. Function is a relation, and a relation between what? A relation between two sets. As Natalie said, the first set we call that input set, and the second set we call it an output set. So it's a relation, okay? But it's not just a relation. It is a very special relation. How special? The special thing over in this relation is that for each input of the function, it assigns a unique output. What I mean over here is that for each input, for each x value of the function, it gives you only one output. Output is the y value. So for each x value, it gives you only one y value. It gives you two y values. That is not the function anymore. Okay, remember that. Remember that. So function is the relation. Okay, following a very special pattern. Okay, and the relation between input and output. But for each input, it gives you a unique output. That's the definition of function. Okay, and what is domain? Okay, let's say this on the x value. Okay, I have to say that it's not correct, but he tried it. Domain is all the x value that make the function defined. Okay, so you missed that part. The later part is very important. It's not just the x value itself. It's all the x value that make the function defined, because there's some x value is not the domain at all. And today we're gonna learn how to find all this x value that make the function defined. It means that we learn how to find domain of the function. Okay, so after you learn how to find domain of the function, you know right away what x value is inside the domain and what x value is outside the domain. Okay, if the x value is outside the domain, it does not belong to the domain anymore, and we don't call that the member of the domain anymore. But all the x value inside the domain that make the function define, we call that the element of the domain. All right, let's take a look at the first example. Example 1. Let me give you a simple one first, okay? Find domain. Make sure you understand it, because this is, I put this type of question on the second assignment. A lot of type of question on this finding domain on the second assignment. Finding domain of the following. Excuse me. fx, okay, equal to, okay, so the function I want you to find domain over here is a radical function, equal to radical 2x minus 1. Okay, let's find domain of this one first. Okay, so when we learn about radical, we already learned that. Oh, go ahead.
Don't we have to square it to get rid of the radical?
The function is radical already. It's a function. It's not a solution. It's not a equation. So you cannot get rid of the radical. Okay, because the radical over here is the question. You cannot change my question. For solving the equation, yes, you can square it both sides of the equation so that you can get rid of the radical, but for the function you cannot. Okay, so what we know about radical, as we already learned, you can take a radical of any positive number. So for example, I can take radical of right here. For example, I can take radical of 0.5, right? I give you 0.707, or I can take radical of 49, give you 7. However, you cannot take radical of negative number. For example, I have a 7 minus, and I hit radical, it give you error. It means what? It means that you cannot take a square root of negative value. Well, of course, some of you already learned imaginary number. Okay, or maybe in high school you learn imaginary number, the I number. Then you can take a radical of the I number. But in that case, that's called imaginary number. It's not a real number anymore. So far we learned that the radical just work for the real number. Okay, imaginary doesn't work. You can get an imaginary number, but when you take the radical of a number, it should be positive number. Negative number doesn't work. Okay, remember that. So it means what? It means that everything inside the radical must be greater than 0. Now I have a question for you. Can we take the radical of 0?
Yes.
Okay. Radical of 0 give you what?
0.
0. So it looks like 0 still work, huh? And all the positive numbers work. However, for all the negative number does not work. And I already show you with my calculator. And because all the positive number and the 0, it make the radical defined. It means what? It means everything inside radical, in this case is the square root one. I'm going to put the second radical. Must be greater than or equal to 0. Because if it's negative, then you take square root, it does not work. Okay. In other words, I can say that radicand is a radicand. This is called radicand. Okay. Radicand must be greater than or equal 0. Okay. So in order to find the domain of this function, I'm going to set up radicand. This is radicand greater than or equal to 0. Okay. So what we have here, we have an inequality, right? How are we going to solve this inequality?
Wait,
Are we gonna move?
Oh, sorry, go.
Are we gonna move -1 to the other side?
Okay, we move -1 to the other side. Everybody agree with Luke?
Yes.
Yes. So we move a -1 means we added both sides by 1. So it means we add both sides by 1 here, you add over here. So this has become greater than equal 1. Okay, I'm sorry again. I'm not going to write +1 each side. Okay, you just do it yourself, or you do a mental math like what I'm doing here. Then what? We're gonna get rid of number 2, right? Because we need to isolate the x itself. So what we're gonna do next?
Divide by 2.
Divide by 2. Oh, so they give you x greater than or equal half. Okay, if we write in interval notation as the final answer, because that's what I'm always asking you to do, it will be bracket, right? Equal, that's why the bracket 1/2 Okay, 2 because greater than half, so to positive infinity. Parenthesis. So this is my final answer. Okay. So what we know about this final answer, it means what? It means that for all the x value that's greater than or equal half, we'll make the function define. So the domain is just those value only, not just all the x value. And Lou said at the beginning of the course, he said that all the x value is domain, but in reality, it's not. Of course, some function, yes, but not all the function. So it says in this function, I give you an example one here, only the x value that greater than or equal half is the domain. Okay, it means all the value that less than a half, it does not work. For example, 1/3 does not work. Or 1/3, 1/3. Yeah, 1/3 does not work. Or -5 does not work. Or even 0 does not work. Because just plug it in 0 in here. Just think about it. If you plug 0 in here, 2 times 0 gives you 0. 0 minus 1 is -1. Can you take square root of -1? No, right? Well, you take square root of -1 and give you error right away. See that? Error. 1 radical error. So only the x value that's greater than or equal half is the domain of this function. Okay, everybody clear? Any concern here for the first example? Of course, on the test or on the assignment, you don't have to write this part. The reason I'm writing this because I just want to give you a better understanding how I can set this up. Okay, so this is like an explanation of why I'm setting this up. Okay. All right, good. We're good, right? Example, any other question or example?
So everything you just did is to solve the square
Inequality
root problem.
Yeah, it's solved inside the radical. Everything I do is basically I set everything inside the radical. We call that the radicand because everything inside the radical, there's a name. That name is radicand. We set everything inside the radical greater than or equal 0. Greater than or equal 0. Okay, so remember that's that. Okay.
I have a question.
Yes.
I really struggle with this on one of the homework. I don't remember which one it was, but like, it's hard for me to know whether to use brackets or parentheses in writing in notation. How do we differentiate?
Okay, so every time you have inequality sign like this, and that include the equal sign, it means that you have to use bracket. If it does not include the equal sign, then you have to use parentheses. But for the infinity, you always use parentheses. Remember that. For negative infinity or positive infinity, always use parentheses. Okay, don't put the bracket over here, because if you put the bracket for the infinity, it's wrong. It's terribly wrong. Terribly wrong. Okay. So if you see the equal, it's bracket. All right, example 2. Now let's find the domain of another function. In this function is a rational function. Let's use a very basic one. So this is a rational function. Okay. Oh, because a rational function is in fractional form. Okay. It's a fraction. So it means that we have numerator and denominator. The numerator is 1. Denominator is x plus 1. Okay. Now tell me, if you take a number and you divide that number by 0, okay, by 0. For example, 2 divided by 0, what it give you?
2.
2 divided by 0.
Wait.
Isn't that impossible?
I forget if it's 0 over 2, that'd be impossible, or 2 over 0. I'm trying to
Okay.
Yeah, divide by 0.
2.
one of those.
Yeah, you
Okay,
can't divide by 0.
Okay. 2 divided. Okay, if you forget, I just use the calculator here. Okay, let's take 2, huh? And I hit the division sign, so 2 divide by 0 and put equal, boom, error. So 2 divided by 0 does not work. How about 0 divided by 2? 0
That would be 0.
divided by 2 will be 0. So 0 divided by 2 works. But 2 divided by 0 does not work. Or any number divided by 0 does not work. Positive number divided by 0 does not work. Negative number divided by 0 does not work. Rational divided by 0 does not work. Irrational number divided by 0. So any number divided by 0 does not work. It gives you error. So it means what? It means the denominator can't be 0. Right? Got the same meaning. Because you cannot divide by 0, it means that the denominator cannot be 0 in order to work. Because if it is 0, then it does not work. Right? So now look at back to our example here. Which part is denominator?
X plus 1.
X plus 1. All right, so x plus 1 denominator can be 0, right? So can be 0. It means can't. Or sometimes we call it this, we can translate this different form. Okay, I mean the bottom denominator can be 0. Okay, so you're going to treat it the same way as equal sign. Okay, so I'm going to solve for that. I subtract both sides by 1. So we have here if x can be negative 1. And if x can't be negative 1, then the other number except for negative 1 will be the domain. It means all other number except for negative 1 will be domain. For example, like what number? Anyone can tell me? What number will be the domain?
2, 4,
2?
anything like that.
Yeah, 2, 4, 7, negative 5, infinity, negative infinity, right? Except for negative 1. Even the 0 work. Okay, so how I'm gonna write that in interval notation? I'm gonna write that. We're gonna write from left to right. Okay, we're gonna write from left to right. So we're gonna go from negative infinity to -1, but we don't want to take it -1 because -1 is not inside the domain, so we're going to put parentheses. Union -1 positive. Again, I mean, on the test or on the assignment, you don't have to write this statement right here. This statement is just the explanation, so that you know when you finish the Zoom meeting with me and you look back the example, you understand why I get this. Okay, so I just give you more explanation in writing. Any concern on example 2? Okay, in general, so if you see the rational function, you just set up denominator can be 0. Okay, then you solve for that. Then the rest of them will be the domain. The reason I put parentheses here, because we don't want to take -1. Okay, because it say can, right? It say can. So this is mean x can be -1. So that's why I use parentheses for not including. I cannot use bracket because if you use bracket, that is included already. Okay, so you have to use parentheses. Everybody clear?
Wait.
All right, I'll stop.
Wait. Explain it one more. Wait, so
That's
brackets?
okay. No, that's okay. That's okay. What part?
When we should use brackets instead of parentheses.
Okay. You see it over here? What does it mean? This symbol means can't. So x can't be -1. If it can't, then of course you have to use parentheses. Right? Because
what does parentheses mean, and what does like brackets mean? Brackets mean
bracket,
it's like everything. Yeah.
Bracket it means included.
Oh, I see. Okay.
So this is mean none included. Not included. We don't want. It means we don't want. -1 in this case, we don't want. We want everything to the left of -1. We want everything to the right of -1, but we don't want -1. So on the graph, it's something like this. So we have -1 here. I have to use the open circle, mean not included. So we want everything here. We want everything
You would use the closed circle if you want it to be included.
Yes.
Okay.
Then if we want to include it, we have to put closed circle.
I see.
All right. Can I jump to the third example now? Example 3. Yeah, I want you guys to be more interactive with me more, because I know you see that it's an online class, and I already said to you that I don't know that you guys, some of you guys here, but I mean probably you guys not here. On Zoom it look like you guys here, but some of you probably not here. But I mean we have to learn, so I mean you have to try to get more information from me. If you don't get it, the problem is just stop me. Okay, I don't mind. So I'm going really slow. All right, let's take a look at this example. I have 2x excuse me, over x minus 1 times x plus 2. Now, tell me right away, is this a rational function?
No, it's irrational because it's in a fraction form.
It's yes or no?
No, because it's irrational because it's in a fraction form.
So this one, what do you think? This is rational or irrational?
Irrational.
If it is, well, I think you kind of reverse the statement already. If it is in fractional form, it is rational. So I can say
am I getting
this,
confused?
Yeah. So this is rational. So this is rational. That's okay. It's good that we fix that right away. Because in fractional form, then it is rational. Okay. We don't have something called irrational function. We don't have that. So we just have rational function. We don't have something called irrational. So you never see any irrational. Don't worry about irrational thing. If you see,
I was like,
some,
I could have sworn I heard you say irrational, but I guess I heard wrong.
Yeah, we have irrational number, but we don't have irrational function. Okay. So everything
Excuse me,
you see,
I did have a question.
Yes.
When doing these before, we had to put them on kind of like a number line to kind of graph them out. Will we have to do these on the assignment? Do that on the assignments?
On the assignment, do I ask you to put on the number line and graph it like this? I don't think so. I don't think so. I remember. I just want you to put it in interval notation. So this is interval notation. This is interval notation. So as long as you put it in interval notation, that's fine. Okay. For my assignment, but I don't know on the test. Okay, because I did not design that test. I used the one created by HCC. So
okay, yeah.
So if they want you to grab it, I don't think they want it, because on the platform it's very hard to grab though. I don't think so. But if they want it, you can grab this with it. As long as you understand interval notation, you can grab it. Okay. So again, because this is rational function, okay, so since this is rational function, so denominator can't be 0. Who care about the top? Because the top right now is just a linear one. Okay. If it is radical, then we have to care about that. But I mean, we have to put that into consideration if it is radical. But if on the top it's just a number, on the top is something like this, which 2x or maybe x plus 5, something like that, then we don't care. Okay, we just care about the bottom. All right. So denominator can be 0. It means what? It means we can set up x minus 1, x plus 3, right? Because that's denominator can't be 0. Okay. Now, how are we going to solve this? How are we going to solve this?
Set x minus 1 and x plus 3 both to 0. And
yeah.
Yeah.
You set up x minus 1 can't be 0, or x plus 3 can't be 0. From here, we have x can't be 1. Subtract both sides by 3 here. So x can't be 3. This is how we can split up, because this is a zero product property. If you remember last on the first day of the semester, actually we talked about first week. This is multiplication sign, and that's why we can split them up into 2 cases. But back in the day, back into that day, that's an equal sign, but right now it's the can't be sign. So, but it's okay. It's the same thing. The way you solve it is the same. So x can't be 1, or x can't be 3. It means what? It means what number will be the domain? Anyone can give me example of a number that will be the domain?
Is it 3
2
supposed to be
minus 3.
negative?
Oh, both of you talking at the same time. I can't hear you.
I was just asking, is it 3 supposed to be negative?
Oh.
Is it x plus 3?
Thank you. Thank you. It's negative.
Yeah.
So what number will be the domain?
2, -2, anything like that. Anything that's not 1 or -3.
Yes, as long as it's not 1 nor -3, then will be the domain. So my final answer will be, because -3 we only goes from left to right. -3, negative infinity go first, then -3. Okay, you have to use union. Between -3 and 1 still work, because for example the loop set is 2 still work as long as it's different from -3 and 1. So -3 and between -3 and 1 still work, and everything greater than 1 work. And that's it. Okay, I'm waiting for your question.
I don't really have any questions, but I just truly believe that these notations and parentheses and brackets are going to mess me up bad.
Remember, just remember, the number you don't take, use parentheses. The number you take, use the bracket. Over here, -3 and 1 you don't take. That's why you use parentheses.
I did have a question.
All right, go.
How come for the in the middle, the -3 and the 1, why didn't we use the brackets?
Because again, we cannot use bracket between -3 and 1, because if you use bracket at -3 here, it means that we still include -3, but we don't want to include that. Even though you put one bracket on the same number, it means included. Okay, and we already say that it's not included. So no matter what you see that number, put parentheses.
Why wouldn't we put a bracket for infinity, like next to the infinity one?
Okay, you mean here or here? This one?
No, next to infinity. Yeah.
Next to infinity. You mean this one?
Yeah. Sorry.
Okay.
No. The screen is kind of lagging, but it's
I'm sorry.
It's right there. Yeah, like where the infinity symbol is, instead of putting a parenthesis there, putting a bracket.
There's no other symbol. Oh,
I mean the infinity symbol, or yeah, just infinity.
You mean the positive sign right here?
Positive, no, at the end.
At the end, there's nothing here. There's only parentheses here.
Yeah, that's what I'm saying. At the end, instead of a parenthesis, why couldn't it be a bracket? Because
you can. Okay, I'll tell you why. What does it mean infinity to you?
I mean, just any number ever, like after 1.
Oh, so you see, that's happened. That's the wrong concept right there. That's why. Infinity means what? Okay, let me ask other students. What does it mean infinity to you guys?
Infinity in math, at least from what I know, means that it goes on forever.
It means it's go on forever. Okay.
Yeah, that's like,
it means it goes on forever. It go on for it never stop, right? It never stop. It goes on forever. It could be trillion. It's a big number. And because it never stops, how come you can include it? How? It's unlimited. There's no boundary. It's like the universe. You cannot put the boundary in universe, right?
I see. Okay.
Yeah. We cannot put a boundary. There's no boundary in the universe. Infinity is like the universe. It's go forever. You cannot put the boundary. And the boundary is the bracket here. You cannot use bracket after this, or even after this parentheses. Okay, actually we don't have something like this. We don't have like this. We don't have it. Either bracket or parentheses. We don't have parentheses, then bracket, or bracket parentheses, or something like this. We don't have that symbol in math. Okay, and that's the explanation why infinity you can just use bracket, because this is infinity. It's go forever. It's universe. You cannot put the boundary on the universe. Okay.
I understand. Yeah.
Yes. The same thing on the left hand side, right? The same thing for the negative infinity here. Okay, it's like universe. You cannot put a bracket there. There's no boundary. Okay. Okay. If you guys love physics, we can talk about physics in the next couple of hours, but I don't want to go deep into that, because we talk about the universe, and we talk about the time and space, and, but let's just stop right that part. Okay, we don't want to go too much into physics. But infinity it means no boundary in universe.
I have a question.
Yes,
So
go ahead.
we put negative infinity when the number is negative.
Right here.
Yeah. When do we put negative infinity?
When you put a negative infinity on the number line. Okay. Let me
No, why is it negative infinity? Because the number is
negative? Yes, because on the left hand side of the number line, it's always negative infinity. The number line like this is 0 right here. And negative infinity here. Positive infinity here. You always go from left to right. So if you go from left to right, you always start with negative infinity. Right? Then over here, what we have not include, so then negative 3 right here, right? So this is negative 1, negative 2, negative 3 right here. We don't want to include it, so you put a circle, and 1 right here, right? 1 right here, we don't want to include it, we put a circle. So everything, everything except for this, except for negative 3 and 1, then will be this, right? The one I'm shading in red. Is it? So going to be what? It will be negative infinity to negative 3, union negative 3 to 1, and union again to 1 infinity. Everything I'm shading in red color is the domain. Everything I circle, because it's a can be right here, will be not inside the domain. Okay, so your question will be can be answered because you always go from left to right, so that's why you always start from negative infinity. You know, actually, because everything below negative 3 still works. I mean, it means x different from 1, x different from negative, x can be 1, x can be negative 3, except for those. Any other number will work, except for 1 and negative 3. So I'm going to put over here a little bit more so that after the Zoom meeting, you know. So does it mean that as long as it can be 1 and negative 3, then it will. As long as it is not, let me do it, it is not, then it will. Okay, it's cool now. If you guys still have trouble with this, after Zoom meeting, you can choose waters again and try to try contemplating, because it's based on what I'm writing here. You think about it and say, okay, as long as it's different, as long as it's not -1 and -3, then it works. Then it means what? It means that we don't want to include -1. And when we don't want to include -1 and 1, -3 and 1, then everything will work. Okay. Any other concept? Example 4. All right. For this example, I can say that this is the hardest of all 4. Okay. Fx equal to square root 5 minus 2x over x minus 2 times radical x minus 2. Okay. All right. Question for you. Is this rational function?
Yes.
Yes. Yes. Because it's fractional form. It is still considered rational function. But this rational function is very different from the second and the third example. Because in this rational function here, the numerator is radical. And the denominator, it also contains radical. So it's more complicated. And because it's more complicated, we have to think more. Okay, now let's analyze the top. The numerator. Numerator here is what? Square root 5 minus 2x. Okay, now let's go back to our first example. Now, first example say what? For radical, right? Everything inside must be greater than or equal 0. So which one is inside part of the radical right here?
5 minus 2x.
5 minus 2x. So 5 minus 2x greater than or equal 0. And now it's easy to solve, right? Subtract both sides by 5. Then what next?
Divide.
Divided by -2. But when you divide by a negative number, do you know what is happening?
You flip the sign.
Uh-huh. So negative divided by negative is positive. Okay. So we just finished the top. Just the top. Now, let's analyze the denominator. Okay. So the denominator, let's go back to the denominator part. Anything that has the denominator. So for in example 2 has denominator, has example 3 also has the denominator. And I say what? Any number divided by 0 does not work. It means that denominator can be 0. Okay. Denominator can't be again, okay, on the test, on the assignment, you don't have to write this. You just show me the work. As long as I see this work, and it's okay. You don't have to write a word like this. The word like this just for explanation. And the denominator can be 0. So we're gonna set up x minus 2 radical times radical x minus 1 can't be. Any questions so far? We haven't done yet. We haven't finished yet, but I stop a little bit here. Good, right? All right. So I'm going to split them up again. This is, I use the zero product property. I split it up. So x minus 2 can't be 0. Or square root of x minus 1 can't be 0. On the left hand side is easy. So x can't be 2. How are we going to solve this? Anyone can give me your idea how we're going to solve this one?
Square root both sides.
Square root both sides. Oh, excellent. Oh my God. It's good to hear that. Square root both sides. 0 square give you 0. So it means x minus 1 can't be 0. This is mean x can't be 1. Okay, so it can be 2, it can be 1. Okay. I forgot the interval notation here. So the interval notation here will be less than, so negative infinity to 5 over 2 bracket. So it can be 2, it can be 1. So it means what? It means as long as it is not 2 and 1. Then it works, right? So if I write interval notation, will be what? Negative infinity go to 1 first, right? Because 1 is on the left hand side of 2. Union 1 to 2. Union to infinity. Okay. It looked like we already finished. But you have to pay attention to the radical under denominator. Consider the radical in denominator. On the first example, I say what? I say everything inside the radical must be greater than or equal to 0. Then we set everything is greater than 0. But the problem that it just works for the case when the radical on the top. But if the radical under the denominator, just think about that. If the radical is under the denominator, then we cannot have 0, right? It means that instead, over here, for example, I say that every time you say the radical, you set everything inside is greater than or equal to 0. But at this moment right now, in the first example I have here, the radical is under denominator. So we cannot set it greater than or equal to 0 anymore. But we set it only greater than 0. Okay, because x minus 1 can be 0. Remember that. So if the radical on the top, we set it greater than or equal to 0. But if the radical under the bottom, we just set it greater than 0. Okay, so from here I have x greater than 1. Then I write in interval notation will be 1.
So are we replacing the old answer with this right now?
The final answer, you say? I can't hear you.
Yeah, because up there you did the radical can equal 0 and you did all that, but now it's changed to it's greater than 0.
Because we have to consider both, not just one of them. Yes, we have to consider all of them. So this one is one of the part of the final answer. This is still one of the part of our final, and this one too, and this one too. So we have to consider all the cases. We have to consider all the cases. So over here it become one positive thing. So this is also considered a part of the final answer. So in this case, we have the final answer as 3 parts. As 3 parts. All right. So how are we gonna make it shorter? Because it look like we have there. This is also final answer. This is also final answer. This is also final answer. We make it shorter. Okay. We need to combine all of these 3 answers here as one answer. I mean, this combining part will be let me give you a hard time, but I just want to show you on the test or on the assignment, try to get the final, but if you can show me this and this, I give you some credit already. Okay, try to show me all 3 of this. So you have to consider all cases. You consider the top case, the numerator. You consider the denominator. Then you have to see if the denominator has radical or not. Okay, if it is the denominator only if the denominator has radical, instead of setting greater than equal to 0 as we used to do, we just set it greater than 0 only. Okay, because as usual, we have to set it up like this, right? Everything inside the radical must be greater than 0. But because this is under denominator, okay, we just set it up greater than 0. All right. So I'm gonna go ahead and graph. I'm gonna graph this. I'm gonna graph this one on the number line, and finally I'm gonna grab this on the number line, also on another number line, and try to see if I can combine all of them together or not. Okay, let me grab the first one. So this 0 right here. 5 over 2 is about 2.5. So 1, 2. So it's 1 here, 2 here. So this is 3. So 2.5 is here. And we have to use brackets, so it means we have to use the dot. And I'm going to shift everything to the left. Okay. All right. Now let's grab the second one. We have 0. Again, we have 0. You make sure that you line them up. Okay. You have 0. You have 1 here. You have 2 here. But this is can be 1 and 2. So I'm going to use the open one. Okay, then I'm shading. We take the middle one too, and I'm shading here. Okay, now let me grab the final one. So 1 here, 0 here. And because we don't want to include 1, so I use open circle. This is positive infinity, it's positive infinity, positive infinity, negative infinity here. So we want from 1 to infinity. Set it. Okay. So after you graphing 3 solution here, and you want to combine this in order to get only one solution, one final one. Okay, next, find intersection among 3 graphs. All right, now we have to find intersection part among 3 graphs. It look like what? Look like what? And so this is we grab it over here also, right? So we grab in here, we grab in here, here. So look like from 1 and 5. See, between 1 and 5, look like the it's intersect each other. It's sharing common. See, this one, the graph, the bottom graph right here, we set it this from here to here. This one we set it from here to here. This one, on the first one, we set it from here to here. However, the second graph does not include 1. Okay, the first graph that include 1. So it means that this one does not share in common. One does not share in common. So my final answer will be 1, comma. Let me see if 2 is share in common or not. 2, this one does not include 2, but this one include 2, this one include 2. But among 3s, okay, it does not share in common. So this will be between 1 and 2. Okay, union with 2, 5 over 2. This is included, right? This is also included 5 over 2 here. This is also included 5 over 2 here. So your final answer will be 5 over 2 bracket. This is final answer. And that's it. Okay, so I think that's all for today. I'm sure that some of you is kind of falling behind a little bit for the last example. I want you after the meeting session. I want you to look at that again. If you guys have any trouble understand of that, let me know, or you can bring it up on the next week. Okay, on the next session. But I mean, on the assignment, as long as you can show me these three here and the graphing, the intersection part will be a little bit harder. Okay, if you can get me the intersection part as the final answer, that is good. If you cannot get it, I just take a little bit off. So don't worry about it. Okay, don't worry too much about that. As long as you understand how to get this, this, and this, then it's okay. It means that you already master 95% already. All right. All right. Any question for me before I take attendance? All right. Let me stop sharing screen and I'm gonna call the name. Natalie Tonorio.
Here.
Yeah, okay. Tamara William.
Here.
Luke over here. I got you, Luke.
Here. I have to go to my next class now. I'll go ahead and go.
Okay. Alberto Villegas.
Here.
Okay. Jasmine Knight.
Here.
Mark Grabo.
Here. Wait, oh, sorry. I thought you said never.
Okay.
You said Mark Grabo?
Yeah, Mark Grabo.
I'm here.
Okay. Elise Brobman.
Here.
Gabriel Rodriguez.
Here.
Emma Renault.
Here.
Okay. Max Alvarez.
Here.
Nadia Dick.
Here.
Fernando Melenas.
Here.
Lauren Felix.
Here.
Emery Sadova.
Here.
Okay, and Tajana Session. So
Here.
all right. Have a good day, guys. Keep working, okay?
You too.
All right. Bye-bye.
Bye-bye.